So 19.1 number 15, we had a word of caution. What did I screw up?
Top one is 0, 2, 3.
0, 2, 3.
Very top. There you go.
Okay. Points. I have points. And a rectangle.
Doesn't like that makes sense.
Okay, good. Then my issue was I was too dumb to
Oh,
compute
no,
the area, right? So I needed to calculate the flux through this thing. So I did the integral of f dotted with the area. I said, okay, this is the integral over s of, what was my vector field? 1, 2, negative 3?
Yeah.
And I was supposed to be dotting this with a normal vector. And last time I dotted with a normal vector, 6, 0, negative 4? Positive 4. Yes, positive 4. And then we normalized by dividing by 1 over 2 root 13, and then we did, okay, the area, right? Our problem was we translated this whole thing into x's and y's, and that was stupid. Because of course this is counting on the change in area on the surface, not the change in area in x and y plane, right? So one way we could compute this is we could plug in whatever the area of the surface is for this integral, because this result is going to be constant. You see that? So if we do this dot product, we'll get, what, negative 6 over 2 square root of 13 times the integral over s, the area. This should be the area of the surface, which of course I can compute because it's a rectangle, right? And it's 2 on this side and something on the other side, right? Gotta use the Pythagorean theorem to figure out that other one. Yeah, so this is 2 and 3, so this is the square root of 13 long. So that's where the other 2 square root of 13 comes from. So I got negative 6 over 2 root 13. And then I need to multiply by the area of the surface, which is 2 root 13. So these guys will cancel and I'll get negative 6. All right, so what's the word of warning out of here?
Don't make it in terms of x and y.
Yeah, don't throw it in terms of x and y if you know the area of the thing, right? Otherwise, you're parameterizing and there should be a conversion factor in there, and we don't know what it is.
Yeah, we didn't do any conversion of the function into.
Yeah, there was no
X and
conversion
Y.
of the function into x's and y's that kind of would have taken care of this. So the other way to do this is to make a function formula for this thing. So I should be able to look at that as a plane, right? And its z is, all right, can you guys read off the slopes? Kind of. So what's the x slope? You go over 2 in the x, and that drops what? 3 in the z. So you have minus 3 halves x. You guys see that? And what's the slope in the y direction? You move
About
2 in the y, what happens to the z's?
2. Stays the same.
Stays the same. So I got plus 0y. And then what's your constant intercept at the z-axis? 3. Okay, so there's my equation of a plane.
0. Or is it 2?
No, it's 0, 1. Okay, so I got z is negative 3 halves x plus 3. So what are fx and fy?
3 halves and 0.
Negative 3 halves and 0. So then my flux integral should be, instead of the geometric way, I should do a double integral, right? Of what?
3 halves, 0, 1, dotted with.
Okay, so I need my vector field 1, 2, negative 3, dotted with
3 halves, 0, 1.
And you have positive 3 halves because the formula has a negative in it. 0 and 1. Dx, dy. And x's and y's, they range from
0 to 2,
0 to 2, 0 to 2. Okay, so that reads like I got the integral from 0 to 2, the integral from 0 to 2 of what? So I got 3 halves minus 3 is negative 3 halves. Dx, dy gives us
-6.
bam, same thing. Good, excellent. So what did we sort out? Apparently I needed to be more careful with my deep area, right? Let's do that. So the formulas, right, for functions, cylinders, and spheres, those are all fine. My issue is with the interpretation of normal vector dotted with d area, right? I have to remember that d area lives on the surface. It's not in the parameters at all.